I'm in the shop today to do something that focuses more on the tinker portion of Tinker and Timber, and that is actually to do something that I'm getting paid for. No, not like that. This is not sponsored content. This is actually something that I'm doing for my day job. I have been asked to test a product to see if it meets some claims that have been made, and so that is what I am going to do. So I have a product that spins, and I'm going to use a tool that a lot of you probably are aware of, but if you've never seen it before, it's kind of a neat tool. They don't have to be ridiculously expensive, although they can get eye-wateringly expensive. And that tool is an optical tachometer. And what this does is it shines a light and it measures revolutions per minute. And that's what we're gonna do on this platen. We're gonna measure how many revolutions it spins per minute, and we are going to write it down. And that is the difference between screwing around in the shop and actually doing science. We're actually taking quite a few measurements. We're gonna be getting ambient temperature, and unfortunately this little guy only measures in degrees freedom, not degrees science, so we're gonna have to convert. And we are gonna be using a digital multimeter to measure the line voltage and just make a note of performance at a given line voltage. Although I don't expect it to vary much because we're on 120 volts AC, and as I put my probes in, I am at 122.1 volts. So I have my setup. The other thing that's important to have is a test procedure. And I realize I'm holding this up like there's a procedure here, there is not. But we do have a test procedure, and the idea is that this is repeatable. I can give this product and this test procedure, and somebody else can duplicate my results plus or minus maybe 5%. For the purposes of this test, that is well within the margins of error that we're looking for, and it is duplicatable, repeatable, and that is what we use as the basis of saying we have measured this with some level of precision and accuracy. So that's what we're gonna do. I will turn this on and we'll do the first one, and I'll record that, and then I will probably time lapse through all of the measurements and all of the readings. But if I have something interesting that I observe, or have something that I want to share, I'll drop out a time lapse and we'll make sure I share it. Otherwise, this should be a pretty quick, interesting, and hopefully short little video on how to measure how fast a platter spins. So the procedure is turn this on, let it run for 10 seconds. So I've got a timer over here. Let it run for 10 seconds to stabilize. Then take the reading for 5 seconds. Then make a note of the revolutions per minute or oscillations per minute, the voltage as well as the temperature, and then turn it off. And then we will use a non-contact thermometer to measure the motor temperature, because again, as part of the procedure, we do not want this motor to be tested at temperatures exceeding 40 degrees Celsius, which is about 110 Fahrenheit. So we will let this cool off between runs if it heats up to above 40 degrees Celsius. So that's our procedure, and let's go ahead and get started. All right, we're gonna turn it on and let it run for 10 seconds to settle. And then we'll take our measurement for 5 seconds. Then we turn it off and we record our observations. So 122.1, it did not change. So our voltage was 122.1. Our ambient is 76.8 Fahrenheit, which will get converted to Celsius. And our speed was 3,364 oscillations per minute was our max. Our min was 3312, and that was run 1. So I will do this 2 more times on the first speed setting, then I'll work my way through all of the speed settings, collecting my observations, and then we will be able to compile our report. So here is where I will drop into a time lapse, and we'll get through this. So it really only took a couple of minutes to run through the 3 tests on the first speed. Now we're going to change to the next speed and repeat. Check and make sure that it's under 40C. So far, it has been staying well under 40C with the high of about 31.6C. So no worries there. I just realized I had to adjust my jig because it was just rubbing the very edge on my laminate and starting to make a mark. And I don't want to damage the laminate. I know it's a shop. I know the laminate is going to get damaged, but I'm not here for that right now. So just changing the angle a little bit. That is an interesting observation. Either I had an errant reading or I wasn't testing properly, or there's something going on, because at the highest speed, it's no higher than at the previous highest speed. So we're gonna treat that as an outlier and we're gonna retest because that doesn't feel right to me. I'm gonna say that I solidly put the blame on myself as the tester. Trust but verify. Let's double check that result. And I'm glad that I double checked that. I must have not been measuring that correctly because I got a result that was more in line with what I would expect to see and slightly higher than the previous speed. Now, because I had an outlier reading, I'm going to take additional readings. I'm doing 3 for every speed level anyway, but we'll take some additional readings just to make sure that that first one truly was a measurement error and not error with the tester or with the device. Okay, as I suspected, I think the first reading was just a bad instrument user because everything else was consistent with what I would expect and seemed to be where I would expect the readings to come out with some variation there. So now we have our data. It's time to take that in, compile it, and send it off. And we've just done science. And as far as what this would be used for in practical applications, we're going to jump over to the drill press, and I'll show you an actual shop application for one of these little optical tachometers. What would you use one of these for in the shop? Well, here's a perfect example. If I look at my spindle settings, they are both on the lowest spindles, which should be the slowest speed for this drill press. And if I look at my spindle speed in RPM, it should be 500 RPM. Now, if I turn this on, it is spinning, but I have no idea if it's spinning 500 RPM, if it's spinning 400 RPM, if it's spinning 700 RPM. So this will let us test and find out. So we'll do a test. I have a little piece of the reflective tape that is needed here to pick up the readings, and we'll turn on the drill press and we'll take a reading. And I am getting 500, I don't know if it'll show up there, 541 RPM. So we're in the ballpark of what we would expect it to see. A little fast, but probably within the margin of error. That's slightly less than 10%, which 10% over, 10% under, not great. That's a pretty big range, but for the purposes of drilling wood, probably not a big deal. So again, we'll test it again just to make sure that we got an accurate reading. And I got 543.3 RPM. Again, I don't know if that'll show up on the camera, but 543.3. So we're pretty consistent, 541, 543. I'm gonna say that that's pretty close to the 500 RPM that the label here tells us. So if you wanted to know exactly how fast your drill press was spinning, for example, this would be a great tool to do it. I'll put a link to this below, not affiliate link or anything like this. This is a really inexpensive one. I think you can get these for less than $30, depending on where you are and where you source it. I got this one off of Daddy Bezos's big website. So it's a great little tool to have in the shop. I certainly would encourage considering it if you've never used one before. And if you've never seen one, it's a cool little thing. Optical tachometer.